Well, hello, this is Nitin Dalhat with the Times. I'm talking today to Paul Williamson, who's the Senior Vice President and General Manager for the IoT line of business at Arm. Paul, hello.
Hello, Nitin. Great to speak to you as ever.
So, yeah, it's great to speak to you. Now, this week you were at the Edge Impulse Imagine conference, and you gave a talk, well, a keynote actually, in Silicon Valley. Tell us a little bit about what you said.
Yeah, it was a great event. I was very focused on what's happening in hardware to support Edge AI. The event Imagine is all focused on how do you really deliver performant AI algorithms to edge devices. And I gave a sort of whistle-stop tour of the sort of upcoming hardware and the available hardware to developers that's emerging on ARM. And so a bit of a focus on how we've brought Helium instructions into the Cortex M line and the later Cortex Ms and the uplift in performance using tools like edge impulses that you can get just by using those newer microcontrollers for AI. And then further moved on to talk a bit about our micro NPUs, so our deeply embedded NPUs for edge performance. And I think, as you know, from Embedded World this year, we launched our Ethos U85. So dedicated transformer support and giving people a vision of what's coming next and what they'll be able to do with that dedicated transformer support was a key focus.
Now, in your talk, I think you gave some examples. One of the things I think I keep coming across is, well, we keep talking about edge AI, but there are plenty of examples, and it is making a difference. But I think sometimes people can't connect the dots with the reality. So I think it might be worth you talking about some of the examples you highlighted.
Yeah, it's interesting. So, Edge AI is allowing people to do sort of new things and things that they might have found very complex to do in the past using AI techniques in edge devices. And an example I may have referred to in the talk was somebody doing agricultural viniculture-based analysis, looking at beetles on leaves or looking for beetles on leaves to decide
Mm.
when they need to treat crops, and able to do that in a very tiny microcontroller. You only need to look for evidence of this beetle maybe once a minute and a simple camera and very limited data feedback. It's did a beetle show up today or not? It's not sort of high bandwidth stuff. But changing from looking for leaves dying across entire fields to and mass spraying of crops, being able to very precisely treat agriculture. So, real examples of where people are deploying. But I also got to look forward at where things are going. So, able to show an example of small language models
Mm.
running on ethos processors for much more complex, higher data rate analysis at the same time.
So we talked about this embedded world earlier this year as well, the SLMs. Um, can we drill down a little bit into what a SLM actually is and entails, and from a practical point of view, on the microcontroller, is it a question of sort of having a specific amount of training data, and is it limited by memory, or how does it all work?
Yeah, so I think people are most familiar with the sort of large language model, something
Yes.
like Chat GPT. And
Mm.
really, that is something that has looked across a mass amount of data to more accurately predict, what is the next token or character to produce from an engine probabilistically, looking for the least or the most probable outcome next based on a series of input prompts. And you can take a similar approach on a much smaller data set. So rather than training across all the available sort of text or these models don't just stick with text. You can move to images and other things. You're able to train across potentially a much smaller data set and therefore have a much smaller number of parameters in the model, and that creates a small language model. And that means that you can then deploy it in a targeted environment. So these are more appropriate for expert systems. So rather than needing to ask the question, you know, uh, teach me a physics principle around thermodynamics or gravity,
Mm.
and
Mm.
expecting to get a completely free-form answer on any topic, you might develop a small model that is an expert model. And so the example I gave was a model that was actually based on 15 million parameters. It was a model
It's,
called
it's a large
based
number
on
still.
it's still a large number, a data set which is tiny stories, which is a load of sort of bedtime stories for children. So
Mm.
therefore, a more limited vocabulary, you can imagine, and a more expert in a specific area, but allows it to then, from a prompt, generate a completely new children's story, and runs it sort of on our micro NPU, even in a fairly moderate implementation of 512 max, which is only a sort of quarter of the potential. It's able to generate about 7 or 8 tokens a second, which is human reading speed nominally. So you've got enough compute in our Ethos U processors to run these models for expert systems at the edge very, very efficiently. And the thing that's interesting, as you point out, is what it does change for the embedded systems is the memory system that you need to support it. Even with only 15 million parameters, you're talking about a model size of about 32 megabytes. So not the typical memory size of a standard microcontroller. So what we're going to be seeing going forward is innovations to go with these micro NPUs of people putting them in system designs with larger memory to store those databases, to traverse, to get answers, and larger local caches. The system we were demonstrating with had about 320 kilobytes of SRAM cache to enable it to hold the weights in real time for the calculations. But it's absolutely something that is coming. But the edge is increasingly about these expert systems rather than these large generic models.
So, I mean, you'll have micro systems and then systems of systems, so that then you can expand and scale as you need to, depending on whether it's a small IoT sensor or something else. Is that right?
Yeah, we saw some really interesting discussion actually from one of the other presenters from Synapse Consulting, a part of Capgemini. Chap Jeff Hebert was talking about the need for multiple different models for specialist functions, and he gave examples looking at a system they'd developed for looking after pets and pet health, and how they'd had to train specific data to use the cat litter tray and the occupancy of the cat litter tray, and associate that with pet health. And there were other examples that were given around fault detection in products on production lines. What looks like a fault in one particular manufacturing technique might look very different from another. So creating models that are local experts for the specific application is quite important. But you also want a system that is flexible enough to potentially adapt. So if you're putting down a manufacturing system, you need a level of compute and memory flexibility that will allow you to deploy a range of different models. You might be running one PCB down a production line, for 1 hour and then switching to something else. And the characteristics of what good looks like might change between those flows. So you need programmability and flexibility in the compute system that you install. So some interesting things coming out in how do we make Edge AI real in real world applications.
And part of the Edge Impulse story is making it easy and no code. How easy is it?
Yeah, I'm impressed. Edge Impulse have done a great job of the sort of data collation and coordination of the MLOps tool flow, and we've done a lot of work with them to plug into that with our compiler optimizations to create a quantized output. That is been well solved, and I certainly commend Edge Impulse on the partnership we've had around making that real for so many ARM systems. I think what Jeff raised from the Synapse perspective was some real world use cases that highlighted that while those areas may be solved, an expert system looking for faults in one particular product requires a level of training data that needs to be collected and is specific to that use case. And you need to collect it in the real environment under the right lighting conditions so that the model can be trained to learn on that specific data set. And that is a problem that is non-trivial. You still need to put down a system that is, from the compute side, that is flexible and can address those needs and can collect that data and refine it and perhaps update the model over time as the system changes. And we've got good compute and tooling, but nonetheless, a level of expertise in development to collect the right data for the target specialist application is required for those kind of products.
But tell me, I mean, you made some other announcements aside from the show. Tell us a little bit about those.
Yeah, this week as well is an exciting week in large language model development. Meta AI have released their latest set of Llama 3.2 models that are widely available. For me, the interesting element of that was that rather than just really large, and while they have released very large configurations of the model, they've also introduced a number of smaller. So at the top end, 90 billion parameter models, all the way down to 1 billion parameter models. And those 1 billion parameter models, for my world and for Edge AI, are very practical and deployable. And so we announced that we've provided support cloud to edge for running of those Llama models on day one with optimized kernel performance running on ARM CPU. So we announced day one support, and whether you're going to go and run those on a cloud instance of Graviton or another cloud provider, or run them on an ARM device at the edge like a Raspberry Pi, the software work we've done with Meta to ensure that these models are supported in early deployment means you'll get a good performance and efficiency when you deploy them on ARM CPUs, which is something we're pleased to continue to drive and support.
And that's accessible through your ecosystem, or how does that work?
Absolutely. So we through our work with we introduced a set of frameworks and kernels optimizations called Clyde, and
Yes.
through our integration with PyTorch, ExecuTorch, and so on, we're able to make this performance accessible on ARM Cortex CPUs across the gamut of edge to cloud. So making that all open and available to our partners.
And what's exciting you over the next few months? What's happening?
We'll be round and about supporting our partners at a range of trade shows, and always interested to support their announcements as they're bringing our products towards market. I think, as you said, we've got sort of new mobile platforms as well, always coming out in the new year, showing new levels of performance in CPU and GPU technology, which are always interesting to us. And already my team are looking forward to what we'll be able to talk about at Embedded World, which, while it doesn't, it seems a long way away in some ways, is fast approaching. So, and new announcements from our partners and from what we'll be doing in both the sort of mobile and higher performance world, as well as all the way to edge devices in Embedded World next year.
Oh, we've got Embedded World in a couple of weeks as well in Austin.
Absolutely. That as well for sort of a new US venue for Embedded World, which will be exciting.
Yeah, good. Well, Paul, anything else? Or?
No, thank you, Nitin. Always good to talk.
Okay, thanks a lot, and good luck.